Just slides. Okay, so this next section's about control flow, and that's just a fancy way of talking about loops and functions, and really kind of how JavaScript goes through a particular set or block of code. So this basically lays out a problem for us, right? Which is code is static, which means when we write a code, like when a computer runs it, we're not writing it on the fly, right? Like, we write code, then we ask the computer to run it. The computer takes that code and it just follows our commands, right? So it's not like we can keep adding things to it as the computer is running it. There are some, and because we also don't write code in a very linear fashion, right? So if you were to give someone directions to a place, you wouldn't say like go to this street and then give them the last step of directions and then go back and give them another direction in the middle, right? You would go from top to bottom. You would say, you do this at step 1, you do this at step 2, you do this at step 3. In programming, that's not necessarily how our code works, right? You can write a function here, you write a function here, you can be calling it here, and then calling it again much later, right? The computer really can't be looking at it from a top-down approach. So, control flow is just a way of saying, how do we think about writing code in a way that kind of optimizes that progression? Go-to is kind of a tangent, so don't even worry about this for too much, right? But just to give you a sense, this is kind of how a lot of other code, a historical implementation of code used to look, right? You would do a bunch of things, right? You would say, if this happens, we log this out. But if I wanted to reference to something that happened earlier, I would say go to and actually give it a line number, right? And then it would then go to line 3, execute on line 3, say, all right, then go to line 15, which then brings down here, right? So, I mean, there's only like, 4 or 5 things here, and you already see how messy it's going. And really, it's in a way that's not really easy for any human to follow along. So it became really hard and unwieldy for people to implement and use. So instead, JavaScript uses something called structured programming, which essentially just means that, hey, let's develop some basic frameworks for code in a way that makes our code really simple to read and also really reusable. And that reusable component is really at the heart of structured programming. Sorry. So just to make sure that we're all on the same page for this image on the far right side, right? Is there anyone here who, like, I guess you've kind of gone through the basic for loop syntax, right? And it's fine if you haven't. Like, I can spend more time on it on a later slide. But some of the example I think kind of takes for granted that you understand how a for loop roughly works. So if that's something that's not quite clear, just let me know, and I'm happy to explain it in more detail as we go through some of these examples. Okay, but in this example here, this is where you're used to see, right? We do a for loop, we execute this block of code, but we do it over and over again until these conditions are being met, and then we call something else somewhere else, right? So this is kind of the modern day version of programming. Okay, loops. So a loop is just a way for us to rerun code over and over again. And really the most important thing in a loop is this last point here, which is that it must get us to a point in which eventually the loop will stop, right? So if you think about a for loop, we tell it explicitly when to stop. While loop, we tell it explicitly when to stop. With any loop, so in modern computers, if you have a loop that doesn't stop, eventually the computer will kind of realize what you're doing and will stop before you and say, hey, did you mean to do something else, right? Historically, that wasn't always the case. And really, even like, in a more practical sense, right? If you're working on a business application and you have a process that runs infinitely, if that's tied to some kind of transaction process or some kind of, payments or charging process, like that could have, really heavy ramifications. So all of that is to say, like when you build a loop, step 1 is always just make sure, okay, at what point would this loop not execute, or at what point is this loop going to apply? And so that's why that last piece says we must always be incrementally moving towards the end of the code execution block. Okay. Loop also, you'll hear this concept called dry a lot in programming. It means don't repeat yourself. If you can write something once, just write it once. And if you can do that same thing 20 times, do it in a loop. It's just a lot more efficient, makes your code a lot more readable. So here, if I want to console log out every number, in increments of 5, I could very well do it this way. This is a very valid solution, but obviously the code is very, very heavy, And so these ways to do with a while loop or a for loop is just a lot easier. Okay, and it also makes the code a little bit more easy to read too, because now when someone scrolls through it, they kind of pick out the most important parts first. Okay. Shoot. Okay. Okay. So a while loop. A while loop is somewhat dangerous, and to be quite honest, I don't really use it that often on a daily basis. But a while loop basically, as the name implies, says, hey, keep doing this until X, or keep doing A until B, right? A is whatever is in the code log, console logs, whatever it is, but A is always what's set here, right? And then B is just a condition, right? This condition has to eventually become false. If this condition is always going to stay true, then your computer is going to keep running whatever's in here over and over and over again. So for a while loop, it's actually very imperative that there is something that happens in your code in this block that has to impact this condition, right? If I say do A until B, then it means something in A has to affect B, so that eventually B will change, and change in a way that will make this loop stop. In most modern computers, if you do something on accident where you say like while true and it runs infinitely, I think after a few seconds, like it may seem like a few seconds in human time, in computer cycles, it's like a few like 100,000 or million iterations, it'll be like, hey, I think this is an accident. They probably meant to kill it. So it won't break a computer or anything, but they will tell you like, hey, it doesn't look like this is going to finish. What do you want me to do? Okay. But all that say that in the while loop, it just says do A until B, and B eventually has to become false. And I think a lot of editors right, will even check in this block to make sure that B is somehow being changed inside of here. If it doesn't, then it will probably throw a warning before it lets you run it. Any questions on while loops? I think the syntax is actually very straightforward and very much like an if statement. This is going to be converted into a boolean, right? Those basically cast as a boolean equals true. Same thing we saw as the if loop. And yeah, so this is a good example of a while loop. Yeah, nothing too much to report here. Okay, for loop. For loop is probably the one that you're more used to seeing, and is the one I think is used a lot more often in programming, really across most languages. So the for loop in this condition here basically it specifies three things, right? One is where do I start? Two is what am I checking to tell me when to stop? And then three is okay, how am I changing it so that I reach a stopping point eventually? And this is actually, and the reason why this is so common is because with a while loop, sometimes there is this element of, hey, I don't know when I'm going to stop, so that's why I use while, right? So if I want to roll a die token, so I get a 6, for example, right? Like it could be 10 rolls, it could be 1,000 rolls. Eventually, theoretically or mathematically, I should reach a stopping point. So that's when I use a while loop. But for a for loop, it's a lot better when you kind of know upfront how many cycles or how many iterations of a process you want to go through. So if we go, and then they use semicolons here to separate the starting point, the expression, and the change. So with a for loop, as in this example here, right, we declare this variable called I, and we start it at 1. Okay, so that's our starting point, which is I equals 1. We stop when I is no longer less than or equal to 5. And then for every iteration, we actually add 1 to I, right? And so when we look here, it's actually like very clear because eventually, like if I was just to read that comment, like usually this first initialization is almost always 1 or 0 because it just kind of makes sense. If you're trying to iterate through every single letter in a string, for example, this would just be how long, like stringed out length. And then this is usually incrementing by in most cases incrementing by 1. You may have like edge cases where you want to do every other one or every third one or whatever, but like for the most part, like a for loop, once you see enough of them, you really quickly pick up on what it's trying to do and which elements it's trying to loop through. Yeah, and then and this is just like a quick example of how, hey, if we want to loop through every letter in the word cheeseburger, the index is at 0, right? So bar I equals 0, same idea. index is less than burger.length, so the string.length, and then we're incrementing by 1 every time. And every time we'll just log out the letter at that particular index. So that's how we get cheeseburger. It's how we iterate through a list, or in this case, a string. One thing to note here is that when we do this var I equals 0, this actually creates this variable called I, and it's used not necessarily just between the parentheses, but also between these curly braces. So you have access to that variable, right? So if you want to know how many times I've run this, or which iteration am I on right now, you can just do a console.log I, and every time it runs, it'll just tell you what number it is. In this case, we're actually using the I for computation. We're saying, hey, if I want to add up every number between 1 through 10, how do I do it? Well, I keep track of a sum that starts with 0, and every time I just add I to it, because I know I is going to be that. The I is a real value that I can also use within the confines of my for loop. Okay, so any questions on for loops so far? This should be reviewed for most of this should be reviewed for folks, right? Great. Okay, this is something that I think I know Andy talked about, or we had an issue earlier with this, right? But break, continues, and returns. Break is probably so I think these go in order of kind of like drasticness, if you will. Like if I have a for loop and it's supposed to run 10 times, if on cycle 6 I run a break, then it just tells it, hey, okay, stop cycle 6, let's run cycle 7. That's it, right? It's saying don't run the rest of the code, but keep going, pick up where you left off with the rest of the loops. The continue, sorry, my bad, take that back. That was continue. Sorry, I was reading this backwards earlier today. Sorry, continue does that. Continue ends this current iteration, and then moves on to the next one for the next cycle for you, right? So if I am counting from 1 through 10 with a loop, if right before the 6, when I say, hey, don't count 6, but continue on, and I was like, okay, great, I'll skip 6, but I'll start at 7. Break basically says stop counting altogether, right? Then you just end the loop. You just end the loop basically at that point, probably prematurely actually. And then return is the one where it ends the loop. It also ends the function in which it's called in, and it gives you back a value. And because it ends the function, as we found out earlier, what it also does is nothing after the return will be run either. So so that's why when you look at most code, return is usually the last line in the code, or it's necessary if or else, right? Because once computer hits the return, it basically it's like that piece of code should be done running. Okay. Any questions on breaks, continues, or returns? Very simple concept that once you use once or twice, it'll become pretty clear kind of where the line or where the appropriate ways to use them are. Okay, logical operators. I think there's only one page on this, right? Yeah. So logical operators basically are Boolean checks, and as we saw earlier today, they kind of work in a certain way where when a computer sees a Boolean, they literally just read it from left to right, right? So it will evaluate each thing between the Boolean marks independently. In this case up here, we have this and, right? So it goes from left to right, and I think Louis may have mentioned this earlier, but and so what this actually, so right now we're saying is, hey, can be president this and this, and it will give us a true value back. But what it actually gives us is this last value, so to speak, right? Like this, what it does is it's converting to a Boolean first, and then doing the checks like ands or ors, whatever it is. And as soon as it gets its result, it actually gives back the last thing that it evaluates. So let me just do a really quick example to kind of make that point hopefully a little bit clearer. Okay, so let's do REPL IT, and let's do JavaScript. Okay. Okay, so if I console.log out true and true, I get back true. Okay, that's to be expected. If I console log out true and 1, I get back 1, right? If I was to put this, so normally when people use logical operators, it is in the context of an if clause or a while clause or like a check, right? And so because of that, it's kind of usually inherently, or it's actually usually implicitly implied that whatever value I get, I'm going to convert to a Boolean. But just so everyone is really aware, we saw this earlier when we were doing the EAE-IOU thing, right? Like what AND and ORs actually give back is the actual element. And it's just that normally when we use it, we're then converting that into a Boolean, which is why we think it usually gives back true and false, when in reality it actually only gives back the last element. Okay, so that's why coming down here, like, you see how we're using it here. In this case, we're using it, it happens to be true, so it worked out. In this case, we're using it in context of an if statement. And really for AND and ORs, it usually is like in a if statement. The only other time I've seen it used kind of without in the context of if is if you have like 6 possible values and they're all nulls until you get to like one of them. You just do, hey, return this and this and this and this, and eventually if you want to hit the first null, like if you want to find the first non-null value, that's also a possible way to do it as well. But for now, at least, just kind of assume that wherever you use it, it will most likely be used in the context of being converted to a Boolean down the road. Functions. Functions are a reusable chunk of code. Okay. The reason why we like functions is because, kind of like as the name implies, right? Like we can call a function from wherever, right? With an if, like if I define an if-else clause, I'm like, wow, that's a really kind of good piece of if-else logic, and I want to reuse it. I really can't, right? I can't just say, hey, copy the if-else from over there. I can literally copy the code and paste it somewhere else, but now my code is going to be twice as long, right? Functions save me that trouble. Functions are saying, hey, just give me a value. I will do all these processes, and I will give you back, a value that you expect. So we saw this with the first exercise today, right? But defining a function doesn't mean you're running the function. Defining the function just means, hey, this function exists. If you want to use it, you have to call it. Go ahead. It's like buying a car. It's not the same as driving a car, right? Like you buy a car, it's there, but unless you actually use it, there's no action taking place. And so if you want to invoke a function, it's just using these parentheses at the end, and if the function also is expecting any kind of arguments, they also pass those in. One key thing to note is, or actually, so before we go there, there are 2 ways to define a function. There's declarative and expressive. Is there a major difference? Kind of, not really. Really up to you. So in both cases, these are valid ways to define a function. When you're declaring it like this, you can actually like this is something that you declare. I mean, the reasons are here, but really, like for the most part, like people do this for the purpose of hoisting, which we'll talk more about when we talk about scope, because hoisting is a really big component of scope. But if this way is a little bit more transparent, or a little bit more transparent to you, this also works. For most of what we do, there's not going to be too big of a difference, and I would say the difference between these two really only come into play if you're dealing with a function, for example, that you want to load when a page loads up right away, right? So look over the slide, but don't get too stressed out right now over which one to use, I guess is my big point here. Like this is one of the things where there is some functionality aspects to it, but don't get too concerned about it at this moment. Okay, so, parameters. Parameters are these things in here, right? And the reason why parameters are really important is parameters are basically placeholders for future values, right? When we define a function, we say, hey, I should be expecting, in this case, a tax and a price. We can write tax and price as if they were real values, right? Because the understanding is that when we do actually invoke this function later on, there will be things that have those values. But for now, they're just placeholders. And so but the great thing about writing them here is that we can write them here as we can start using them in the function. But if we invoke the functions without those parameters, the function will fail. but this just gives a way to start writing it so that if someone does use it, um, it's gonna be valid. And for that very reason, like parameters usually are things that I would put a little bit more effort into naming, just because if someone looks at a function, it's actually even less clear oftentimes what it's doing or what it's operating on. And then the argument really is just the flip side of it, which is that the argument is the actual value that the parameters represent, right? So if I have a function that calculates coffee price and tax, if I actually call that function, I need to give it the price and the tax, right? So the argument is the actual value, and the parameter is kind of what. Sorry, the argument is the actual value you're feeding in the function, and the parameter is just what those values are called within the confines of the function. One really quick thing to note there is actually even when you call a function, this is not what this is. Oh, sorry. So this is not what it does exactly, but conceptually it does something very similar. Where if I have a function, I call it David, and I feed it something called param1. What it's really doing is it's kind of doing something pseudo like var par1 equals whatever value I give it, right? So even though you don't see it in the code, this is kind of subtly what's happening behind the scenes. It's creating a new variable called this and giving it the value the argument that you pass into the function. Okay. Okay, cool. Return. The return keyword passes data back, and it's really the last line of a program, really, right? Like nothing, like the return exits a function. So by definition, anything else in the function that you still want to run after the return is just not going to run because the computer is going to say, great, I fulfilled my purpose, I'm done here. And the other thing to note, and this is something that won't probably, it may or may not come in handy, is every function is going to return undefined by default unless you tell it to return something else. I mean, in a lot of cases, like you might not even need a return, and so whether it returns undefined or something else, it's fine. You don't really care. But just know that by default, it's going to return undefined. So if that's going to affect your code, then just be very, very clear on the last line. If you don't want it to return undefined, you can say return 0, return null, return something else, right? But just kind of keep that in the back of your mind that all programming languages really have a default return. Yeah, and JavaScript is undefined. So in this case, this console log here on the far right, that's not, or on the far right, that one's not going to run that because it comes after the return. Okay, so yeah, I mean that was pretty much it for loops and control flow, right? Loops really help us kind of write clean, reusable code, and we invoke it by passing it in arguments, which within the body of the function become what we call the parameters, and then just something that you'll learn either the easy way or the hard way is that return always ends a function. So when you write it, just be very, very clear about what you want the return to do, because that's the last thing that's going to be called within the function. Okay, cool. Any questions there on control flow, loops, returns, etc.? Cool. All right. I mean, you guys have, I think 45, 50-ish minutes until 6:30. So I'll open, I mean, the workshop actually should already be open. I'll send out pairs now, and I'll probably call out one like pair programming switch around like 6:10-ish. So maybe 20, 25 minutes in. Feel free to work on it at your own leisure. Because we're supposed to get out here at 6:30, I'll probably do the review for these problems first thing tomorrow. So if you want to finish up the problems tonight, or just look at it, tomorrow morning we can discuss it first thing. Sound good? Cool. All right. I'll send out pairs right now.